How does condensation create dry ice fog? Imagine standing near a bubbling pot of hot water on a chilly day, watching your breath turn into mist. Now, picture a similar process happening on a much larger scale, creating a thick, swirling fog. That's what dry ice fog is all about. When you place dry ice, which is solid carbon dioxide, into warm water, something fascinating happens. The dry ice doesn't melt into liquid water like ice cubes do. Instead, it skips straight to becoming carbon dioxide gas through a process called sublimation. This means it turns directly from a solid into a gas without passing through the liquid phase. As the dry ice sublimates, it produces a very cold carbon dioxide gas, which is much colder than the surrounding air. When this super cold gas mixes with the warmer, moist air above the water, it causes the water vapor in the air to cool down rapidly. This sudden cooling drops the temperature below the dew point, which is the temperature at which water vapor turns into tiny liquid droplets. These droplets are so small that they stay suspended in the air, forming a visible fog. It looks like a cloud hugging the ground, but it's really just countless tiny water droplets. The cold carbon dioxide gas is denser than the surrounding air, so it tends to sink and spread out in a downward flow. This is why the fog often appears to flow and swirl around your feet rather than rise up like typical fog. The amount of fog you see depends on several factors. Hotter water produces more vapor, which means more fog. The size and amount of dry ice also matter. Smaller pellets sublimating faster create more fog initially. Humidity in the air can influence how thick and long-lasting the fog will be too. This entire process is a perfect example of how thermodynamics works in real life. It involves phase changes, where dry ice sublimates, and heat transfer, as the cold gas cools the moist air. The difference in gas density causes the fog to flow downward, creating that mysterious smoky effect. So next time you see dry ice fog, remember it's all about cold carbon dioxide gas cooling the air and water vapor condensing into tiny droplets. It's a simple yet captivating demonstration of how gases and phase changes interact in thermodynamic systems.